Hello, welcome. I've been showing you on my other videos how reflection works and how everything you see is a reflection. Now I'm going to show you how, when applied to our greatest sums, it adds up. So first of all, we'll start by looking at the alphabet. As you can see, through reflection I found the numerical value of each letter. When I added these up or totaled these up, we had 33, 66, giving us a total of 99. This gave us a trinity of 369 and E for equals time. Now add those up and of course you get 18. So moving up, I then applied that to this math. Out of this sum, 369, which is 18, and E equals time, I found 30 reflections of this sum. So now I'm going to show you how applying reflection to our greatest math puzzles works. So first of all, we'll start with pi, which is up here, pi. So time is E. The reflection of time, how we all see, is the number 3. Okay, so time, reflection, give us this number. It is the Fibonacci sequence, so infinite. So time, number, or time reflection, infinite. And then if you add these numbers up here, 3, 1, 4, 14, 59, 14, 23, you get 110. Now that's important because if you write the 110 as 110 and then reflect, turn it 90 degrees, you get equals 0. So I thought that was pretty good and I thought that was correct at the time, of course. Now we've gone a bit further down. I now realise if you take the 110, 1 is the divider, and use the other 1 to separate the circle, you get the perfect symbol for circumference and diameter. So time equals reflection equals infinite number equals circumference diameter. And I also realised that if you take the 110 and use 1 as a divider, 1 as an I or a 1, and then reflect the 0, you get 18. So 18. So we'll move on to Newton now. So Newton, 2 planets, 2 spheres. This is what it's about. You'd only get a constant if both planets or spheres were of exactly the same size. So the constant's going to be variable. It's going to be moving about. So taking that into account, we have I, which equals force, E, which equals time, and 3, which is the mass, or it's the reflection. So reflection of time is mass. Okay, everything you see is a reflection. So 3 is the reflection. So we've all seen this diagram here before, and here I think is how it should look. So we take E, which equals time, and 3, which equals reflection, or mass in this case. So now how do we calculate it? This is how we do it, using reflection. Take both E's, write them up here, reflect them to each other. Join them together and you'll see you get an 8. I is false, so apply I, so you get 18 or I8. To get the number, it's 3 and 3 squared, give us 12 squared. 12 squared is 144. So simply, 1 plus 4 plus 4 is 9, and 18, it's a reflection. Still not convinced, I'll show you. So we are in a rhombic triacontahedron. This means this is what everything is. And to prove this, it has 30 faces. Now remember I was telling you that when I calculated this there was 30 reflections. So it has 30 faces, 60 edges, and the dihedral angle is 144. This is what we're dealing with. So 144. So faces, let's break it down. So 30 brings us to a base number of 3. Edges, 60 brings us to a base number of 6. And dihedral angle 144 brings us to 9. Giving us, of course, 3, 6, 9. So to write it as I've been showing you is 3, 6, 9. E equals time. 3 is the reflection. Now, to show you why 6 and 9 are also the reflection of time is look at this. Capital E is a 3, easily. Lowercase is a 6 and a 9. And of course the 6 and the 9 also reflect each other. So time equals 3, 6, 9, or 18 as a total, I8. So if we come back up here, we'll look at Newton. This is how it should be written. Now, I'm undecided on one thing, so you decide. So anyway, so force and time equals mass or reflection equals constant time equals I8 12 squared. Now I think this is probably should be variable time because it's variable, so it should probably be VT. But also you'll see in reflection it actually says I am E, I'm CT, or I'm time, or central time, but it also says TIME in reflection, C time. So that's a pretty good proof. Still not convinced? What we'll do next is we'll tackle Einstein. So down the bottom here, we see Einstein, E equals mc squared. That's not correct. Apply reflection to it. E, the reflection of E, of time, is 3. So, time reflection equals E3. Now we know an E is a 3, so 33 squared. And of course 33 squared is 18. How do you get 18 from that? Well, 1089, which is 33 squared, add them up, I8, 18. And just to prove this, there are a further 6 dimensions from this, 7 in total. There's 7 reflections of this in total. And if you do the math on each one, so the next one, who we got here, time reflection equals E6. This time it's 36 squared. 1296 equals 18, or I8. Now you can apply this, like I said, there's 7 reflections, and you'll find 6 come to 18, I8, and 1 comes to 9, which is the source. So, that's Einstein looked at, that's Newton. And as you see now, we have the same answer for each thing. So, I8 or 18 for Einstein, you can say I8 144 for Newton, and pi you can actually say either. I like the symbol because it's the perfect symbol, but you could also say I8 for pi. So reflection, when applied to our biggest sums, works, and now it's proven mathematically. So I hope you enjoyed it. Obviously it's a real revelation. I've finally got to sort of the core. I'm going to put another video on in a minute which will show you how these 7 dimensions are drawn up in a picture, and I think you'll be amazed. So make sure you have a look at that, and please watch the other videos. Obviously some of them are a little bit out of date because I've been updating as I go along and learning myself as I go along. But I think now we've got to the core, I8 being the one. And here, from the very first reflection when I've done that, I've showed you how taking these 30 reflections, I can build a picture of the universe. So please watch the other videos, I'm sure you'll find it interesting. So this, you could say, is time calculated for the first time. Right, thanks, make sure you watch the other videos. Bye bye, peace to all.